In example one, we're given a situation here and we want to figure out the probability or the percent of the data that fits between the numbers. So let's read this here and see if we can figure out what's going on. If you haven't already, take a look at the concept video. It explains why all the percentages are the way that they are, or at least what they are. So a normal distribution here has a mean of 33. Well, I'm going to put that right in the middle right now. That's exactly where the mean is going to go, right in the middle. Half the data lies to the left of 33 and half the data lies to the right. There's also a standard deviation of 4. So that's right here. You're going to want to know these two things. So the mean is 33 and the standard deviation is 4. And in the concept video, we didn't get a chance to use actual numbers, but now we are. So we're going to go to the right now. We're going to add 4 to 33. So 33 and 4 is 37. And then if you add another 4, that would be 41. And then if you add another 4 to that, you get 45. Moving to the left, we're just going to subtract that standard deviation. So 33 minus 4 is 29. 29 minus 4, 25. And then 25 minus 4 is 21. So we've kind of built our normal model here, or a normal distribution, using actual numbers this time. And it says find the probability now that a randomly selected x value is given on the interval. So the percentage here is going to be the probability, the same thing that we looked at in that or in that concept video. Let's take a look at the first one. So the first one here says what percent of the data, or how much data, is between 29 and 37. So 29 is here and 37 is here. And if we look at that concept video, luckily I have that saved right here, we see that 68% of the data is between one standard deviation below and one standard deviation above. So my answer here is going to be 68%. For the next one, we've got between 33 and 45. Oh gosh, let's see here. So we've got 33, that's right here, and 45. So that's from the mean to 3 standard deviations above. Now that's almost going to be 50%, but not exactly. So if we look at our normal model here, that's all drawn out for you. What we'll do now is we'll just add up everything from the mean to 3 standard deviations to the right. So that would be 34 plus 13 plus 2.35. Or if you prefer, you could take 99.7 and divide that by 2. And we should wind up with the same thing. I think it's 49.85. I don't know if in the video there I said 13 or 13.5. It definitely should be 34 plus 13.5 plus 2.35. And that gives us 49.85. So you're really looking for like this part and this part and this part right here. And the reason why it's not 50 is there's still a little bit to the right of 45. Not very much, but just a little bit. So we can do 49.85% here for this one. Now here we have at least 25. So that's going to be, oh geez, I think 25 or more, right? If it's at least 25, 30 would work, or 40. So for this one, we're going to be looking at every piece of the data. Let's see what other color I can use here. To the right of 25. So here's my 25. And I want everything to the right. So I know that everything from here to the right is 50%, like all of the data to the right of the mean is 50%. And I also know that this piece is 34% and this piece is 13.5%. So if you look above, you can see that here in red actually. Even though the red items to the right don't total 50%, they get real close. And if you continued forever to the right, they would get 50%. And then you've got your 34 right there, and then your 13.5 right here. And we're looking at 2 standard deviations lower than the mean all the way to the right. So we're going to add these guys up, and we're going to get 50 plus 34 plus 13.5, which would be 97.5%. 97.5%. At least 29. Well, we could just take away 13.5 here, I think. So we're going to get 84%. So here's what that would look like. So instead of making my mark here, and worrying about between 25 and 29. I'm at least 29 right now. Oops, deleted part of the part of one standard deviation to the left there. And so now I'm right here, and we want everything from here to here and everything to the right as well. So that's 34 plus 50, which is 84%. And now we have at most 37. Okay. So now we're looking at part E here, at most 37. So that would be 37 all the way over here. If it's at most 37, it can't be more than 37, but it could be less than 37. So I know that all the data to the left of the mean is 50%. And then I know that this little category right here from 33 to 37 is actually 34% of the data. That comes from our empirical rule. So if we add those two up, we get 84%. Now looking at most 21, this is going to be a tiny amount of data right there. Oh my gosh. So let's see if I can highlight that, and we'll try to pick a different color here. Maybe yellow. Hopefully you can see the yellow on the screen. So we're looking for everything like in this little part, this little guy right there. Well, let's see. What we could do here is we could figure out, oh boy. We could just take, well, couldn't we take just 50 and then subtract each piece that we see to the left of the mean? So here's what I'm thinking. Maybe we should do, let's see, we've got 13.5% there. You've got your 34% here, and then this little guy is 2.35%. And if we take all of that away from 50, that will leave us with this guy right there. So everything to the left, minus 34, minus 13.5, minus 2.35% is going to give us this little area here in yellow. And I believe that's 0.15%. There's not a lot of data to the left of 3 standard deviations to the left of the mean, or 3 standard deviations to the right, but for that matter.